If we're given the indirect proof, if 3x minus 11 is less than 13, then x is less than 8. The first thing we want to recognize is what comes after if is our given, and what comes after then, the conclusion, is the thing that we are trying to prove. So again, we might call it the conclusion. In a conditional statement, it is the conclusion. The given is the hypothesis. So our step one, this is a three-step type of proof. In step one, we claim the opposite, or we assume the opposite of what we are trying to prove. So we're trying to prove x is less than 8. So we're going to assume x is greater than or equal to 8. In step two, we're going to make a table, and our rows are going to be x and 3x minus 11. Now our x values we want are 8 and then numbers bigger than 8. So equal to 8 and larger than 8. And in the second row, we're going to put those values in. So 8 times 3 is 24, minus 11 is 13. 9 times 3 is 27, minus 11 is 16. 10 times 3 is 30, minus 11 is 19. So when x equals 8, 3x minus 11 is equal to 13. And when x is greater than 8, 3x minus 11 is greater than 13. Now this is a problem, right? The problem here is that the given says that 3x minus 11 is less than 13. But when x is 8, 3x minus 11 is equal to 13. Those are not the same thing, so this is contradicting what the given has told us. The same happens in the second. When x is greater than 8, the 3x minus 11 is greater than 13. The given says it has to be less than, so this also contradicts the given. Since both of these are contradicting what have to be true, the assumption that they came from, that x is greater than or equal to 8, must be false. Since it's false, and there's only three choices here, right? The three choices we have are what we're trying to prove, x is less than 8, or the two others, x is greater than 8, or x is equal to 8. Since those two are false, the only thing remaining must be true. In step 3, we are basically going to restate that. So both of these statements contradict the given. That 3x minus 11 must be less than 13. So our assumption that x is greater than or equal to 8 must be false. Therefore, since those two things are false and there's only three choices, the remaining thing must be true. So therefore, the original conclusion that x is less than 8 must be true. So in a quick walkthrough of what we did here. So first, with the conditional statement, the hypothesis that is the given. So if 3x minus 11 is less than 13, that 3x minus 11 is less than 13 is given. It must be true. Then x is less than 8 the conclusion to the conditional statement is what we're trying to prove. In step 1, we assume anything that's not what we're trying to prove. So we're assuming the opposite of what we're trying to prove. So here, that is x is greater than or equal to 8. This would be x is greater than 8 or x is equal to 8, right? These are the only 3 choices. Either it's less than 8, greater than 8, or equal to 8. Those are the only choices that we have. In step 2 then, we make a table of values with values that fit the assumption that we're making. So we have x is equal to 8 and greater than 8, 9, and 10. Find what those values are, and the when x is equal to 8 and the 3x minus 11 equals 13. These are just statements that say what the table said. In step 3, we recognize that these statements contradict what we've said has to be true in the given. They are not the same. They do the opposite of what we were saying. That means that the assumption we made had to be false. So if it led to a contradiction, it led to a false statement, then the assumption itself must have been false. Therefore, the original conclusion, the only thing remaining, had to be true. And that's it. That's an indirect proof.